So in this video, we want to talk a little bit about numbering systems. We'll start out by talking about what the purpose of numbering systems is and how it developed. I think back in the day, basically people used things like hash marks. So, for example, it might have looked something like this. People counted days like this. But there was no real symbol or words that we used to explain what those hash marks meant. So somewhere along the way, we developed symbols. And those symbols in our decimal system are things like 0, 1, 2, 3, 4. And we're going to go all the way up to 9, 5, 6, 7, 8, and 9. And so we developed these symbols to express what we meant by those hash marks, to somehow quantify or apply a quantity to whatever those hash marks were. And so we talk about these numbers today as just very incidentally because we know what they mean. And these are the symbols that we use to describe that. So we also want to talk about, before we get into the various numbering systems, this concept of bases. Now we're going to do it with respect to the decimal system just because that's familiar to us. So the concept of bases, in this particular numbering system, the decimal numbering system, we have a base 10 system. And what that really means is how many symbols do we have that represent the quantities that we want to describe? We have 10. So the decimal system is a base 10 system. Base 10 system because we have 10 symbols that describe or help us to quantify various values. Okay, all that being said, let's go in and do a little bit of work with the decimal numbering system. We're going to start, we're just going to pick a random number here, and let's just take 4, 3, 1. Well, each one of these numbers, the 4, the 3, and the 1, hold a particular place value for us. Now, what does that mean? Well, basically, we have the ones place, and I'm going to do a little bit of work here. The tens place, and the hundreds place. The hundreds place. Now, we define these using exponents. So the 1 is basically described as 1 times 10 to the 0. 1 times 10 to the 0. Now, where does that 10 come from? What does that mean? Well, it's a base 10 system. So we multiply it by some factor of 10. In this particular case, it's 10 to the 0. We've raised it to a power of 0. And any number raised to the 0 power is simply 1. So this is going to be 1 times 1, which gives us the value 1. And that's what we have in this particular place, in that 1's place. In the 3's place, or I'm sorry, in the 10's place, we have the value of 3 times 10 to the 1. Well, any number raised to the first power, the 1 power, is going to simply be whatever that value is. So this is going to be 3 times 10. 3 times 10, which gives us 30. That gives us 30. And then the next place is going to be 3 times 10 to the second power, which is going to give us 3 times 100. I'm sorry, that should be a 4. 4, which is equal to 400. Now, if we add these values up, 400 plus 30 plus 1, we have just arrived at the value 431. So we basically translated this using our numbering system. And this is the base 10 system. Now, we're going to back up here a little bit. The binary numbering system, which is a system that we use very frequently in dealing with networking or computers, things like that. These are how computers operate internally. And I'm going to show you why that is. So the binary numbering system, binary, is a base 2 system. Base 2 system. And so in this particular numbering system, we represent all quantities with the value 0 or 1. We've got those two values that we use. Okay? And as in the case of the decimal numbering system, we're going to raise those to a power. So let's say that we've got 4 spots here. And I'm going to turn each one of these on for the sake of our illustration. I'm going to give them all a 1. Now, in the binary numbering system, and the reason that it works so well when we use it in computer applications and in networking applications is because this essentially represents either on or off. It's either on or off, or true or false. It's either one or the other. In this particular system, we have every bit is turned on. Now, we could carry this out as far as we wanted to, but we're only going to use 4 bits for the sake of our illustration. So in this particular case, this is going to be 2 to the 0. This is going to be 2 to the 1. This is going to be 2 squared. And this is going to be 2 to the 3rd. Okay, so we're doing something, again, very similar to what we did in the decimal numbering system. If we back up here, we raise that 10 to the 0, that 10 to the 1, that 10 to the 2. If we had gone out another one, it would have been 10 to the 3rd. So it works in a very similar fashion, but again, with a different base. So in this case, my 2 to the 0 is 1, because any power raised to the 0, or I'm sorry, any number raised to the 0 power is going to be whatever that value, is going to be 1. 2 raised to the 1 is going to be 2. 2 squared is 4. 2 to the 3rd is 8. And as we did with the decimal numbering system, we simply add these together. And that value gives us 15 in decimal. So this 1111 is equivalent to the value 15 in our decimal numbering system. So that's just an example of how we would use the binary numbering system. And now we are going to move on to the hexadecimal numbering system. We're just going to pick a random value, but I want to show you what the base looks like first with the hexadecimal numbering system. So we've seen what it looks like with the decimal numbering system. It's 0 through 9. We've seen what it looks like with the binary numbering system. It's a 0 and a 1. Well, the hexadecimal numbering system is a base 16 numbering system. So we're going to use all the values that we did with the decimal numbering system. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But that's only 10 representative symbols, and we need 16. We need more than we have here. So what we're going to do is we're going to begin to use letters. We're going to say that's A, B, C, D, E, and F. And you'll notice that that gives us 16. And the hexadecimal system is a base 16 system. Let's translate this a little bit, and let's indicate this in the decimal numbering system. This is going to be 10. This is going to be 11. This is going to be 12. That's 13. That's 14. And that's 15. Now you may say, well, that's not 16, but we're using 0, too, as our a value or as a placeholder in this numbering system, which gives us 16. So now that we've established where our base is, that base 16 system, let's just pick a random number. Let's in the hexadecimal system. Let's say CE3. Okay, so we've just used values here from our base 16 system, and let's go ahead and do some translation here. All right, let's do some translation. So our first value is going to be 3 times 16 to the 0 power. Notice again, we're using the same exponential increments in this numbering system that we did in the previous numbering system. So that's going to be 3 times 16, I'm sorry, 3 times 1. We'll just leave that 1 there. So that's going to be 3 times 1, because as we remember, any value raised to the 0 power is going to be 1. So the next one is going to be E times 16 to the 1, which is going to be E times 16. Okay. Well, so what does that mean? Well, we're going to translate that again. We're going to take the decimal value for E, and we're going to use it in this calculation. That's going to be 13 times 16. 13 times 16. And that gives us the value 224 in decimal. 224. And then we're going to take the value of C times 16 squared. Again, we're going exponentially up, incrementing by 1 each time. And that is going to be C times 256. And if we look at the value of C, C is going to be 12. So that's going to be 12 times 256, which equals 3,072. Now we're simply going to add these values as we did before. So if we add our 3, our 256, and our 3,072, that gives us a value of 3299 in decimal. So what are we saying? Well, this value here that we established initially as a hexadecimal value is equal to the decimal value, 3,299. And what we've done here is really to show that translation process. So that's what that looks like. Hopefully what we've done here today is give you a good snapshot of 3 numbering systems and kind of how we navigate through each one of those numbering systems, from decimal to binary and decimal to hexadecimal.